Okay, so a moment ago I got cut off in the last video, but so we were calculating these indicator values of these empty cells, and came up with -8 as our indicator value here. And so then we make this change. Oh, you know what? Actually, I'm not sure if I finished this or not, but there are before we make this change to 34112, we need to check these other two remaining cells, and so that's what I've done here and here. Is I checked the indicator value of the cell shaded in yellow, and you can double check my work, but the only possible circuits are the ones that I've indicated here, and they both have positive indicator values, which is bad, right? So those indicator values would mean that it would be more expensive to make that change. So the long and short of it is that the only cell that would be advantageous would be, or the only cell change that would be advantageous would be this one here. Okay. All right. So we're going to make that change. And what you see on your screen now is once I've made that change, then I need to do the process again. So I have another 4 empty cells again that I want to check. And I've already done this, so to save you the pain of watching me go through it, let's just look at the first one just to kind of indicate how this goes. So this cell right here, the only possible circuit is the one that I've outlined, because all the other ones would either end up with me taking away from a zero cell, and so they wouldn't work. So for example, if I try to go here, down here, that won't work because that's empty. And if I try to go over all the way, then plus, minus, that one's empty. And so that won't, none of those will work. Okay, and of the 4 empty cells, the only one that has even a negative indicator value is this one. So this choice down here, okay? And so I want to make, that tells me that it would be advantageous to make that change. But there's another thing, interesting thing here about this particular circuit, which is notice that the minimum of this circuit is 2. So if the minimum is 2, that means that I can actually ship 2 from this cell rather than just 1, because I can take 2 away here. So none of these point values is, that's 3, 4, 2, and then that one's going to be 2. So that means that's good. That means I can ship 2. And so we are going to do that. And so now let's try the new arrangement. This will be, maybe I should copy the old one. Yeah, let's make 2 copies so we can clearly see kind of how we're changing things. So this is 3, 4, 1, 1, nope, sorry, 4, 1, 1, 2. That's what we did have. And now what I want to do is move these 2 over here and follow this circuit. Okay, and so that would give me a 2 here. This would now be a 0, okay, in which case I've got to add 2 somewhere, and the 2 that I'm going to add is right here, okay. But if I add 2 here, I'm going to take away 2 here, so that's going to be now 1, and then my other 2 values will stay as they are. And let's double check that our rim conditions are still good. So 3, 7, 1, 8, 1, and 2. And so this is good. And now we have, what's the cost of this, of our transportation feasible solution? Sorry, what's the cost of our feasible solution now? So it's going to be 8 plus 6 times 9 plus 3 plus 1 plus 2. So that's what? That's 8 plus 54. Oh, my calculator's being bad. 8 plus 54 plus 3 plus 1 plus 2. And that's 68. Okay, so just to keep track of kind of where we came from when we started this way back when and ignore all the stuff I'm scrolling through, our original cost was, I don't even remember, what was it? Not, well, we got it down, 78, right? 78, 3511. Yeah. So we have improved for sure. And now you would like to be done, and I'd like to be done too, but what we've got to check now is we have 4 cells now that we need to see what the indicator value is of each of these. And basically what we're looking for is for all of these to be positive. If all of those indicator values are positive, then we have no more advantageous changes to make. So we have to check it again. So let's get started. And I'll see how quickly we can do it. Maybe we're getting better at this, so we can move more. We can move a little faster. All right, so if I start here, the only possible choices are here. That would be possible, and plus, minus, and that's it, actually. No, that's not true. I could also go them this way. That would work too. So let's check the value of each of those. This one would be 15 minus 8 plus 9 minus 1. I can tell you right now that that's positive, so that one is not going to help us. And then the lower one would be 15 minus 1 plus 3 minus 1, which is also going to be positive. So I don't even really care what the value is. I can tell that's going to be, when I sum those up, it's going to be positive. And so neither one of those is going to be a help to me, and therefore I know that that's a positive indicator value for that cell, and so I won't bother making that change. So now let's check another one. All right, I'll just go to the next slide. And easy to forget what we're doing, 16112. And we want to check. So we did this one. So we've got, oops, sorry, that was the wrong picture. We did this one, so we've got these 3 left to check. Okay. So let's check them. I'll start here. And I have 2 possibilities, that one or, but actually notice that this one is actually not even, like I don't need to check that because I actually did it over here, right? So I did that, that's the same circuit, so I won't worry about that. I know it's positive. So then the only other one I could bother with would be this one. And so that'd be 3 minus 9 plus 8 minus 1. 3 minus 9 plus 8. And so that would give me positive, right? That's going to be negative 10 plus 8 is negative 2 plus 3 is positive 1. So that's no good. So I don't need that one either. And so now I can move on and check 2 more. And right now I'm going to check this one. So I'll start here, plus. So my only possibles, plus, minus, plus, plus, minus, plus. Nope, that won't work. Plus, minus, plus, minus. So that will work. So that one would be 5 minus 3 plus 8 minus 1. And that is positive. I can tell that's positive. So that's no good. And that's the only circuit that I could even do there. So that means this cell is out of the running. So we only have one more to check, which is this guy right here. And let's see what we see. And now some of these, actually some of these we kind of we're doing kind of some redundancy here. We've checked things already, but it's hard to kind of keep track of what we have and haven't checked, so that's okay. Let's just do it. So plus, minus, plus, so that won't work because that'll have a negative. So the only one that's going to work would be this one. And the cost of that would be 12 minus 3 plus 9 minus 1. And that's positive. Okay. So the lesson here is, at this point, all cells, indicator value, all empty cell, indicator value is positive. Are positive. So that means that we don't need to make any more changes. So we have reached a solution that is as good as it can be. Okay. Now that's this solution here. I mean, it's on all of them. 16112. Okay, and then the cost of this was 68. That's our transportation cost. Okay, so it's kind of a long slog to get through that, but that's one way to optimize this solution. So we have kind of shuffled things around. We can't make this any better. We can't kind of shuffle things from one cell to the next in any way, and all the empty cells have positive indicator values, and therefore it would be not to our advantage to make any more changes. And so this is it. This is our optimized solution. Okay.